Wonderful. So you made it to the last video of this series on getting an intuitive understanding of the Newsvendor model. Right, so this is where we ended the second video, saying that how much to stock had something to do with underage and overage. And just to recap, underage was the cost of angry customers, that means lost customers or lost sale. And overage was the cost of having excess products that we have to dispose of or sell at a discount or something like that. So again, as usual, let's get rid of the clutter and let's get everything useful on one side. Right, so let's begin this last video. Now, you'll have to stay with me till the end here. This is a bit involved. So be peaceful, patient, and stay with me till the end. Right. So just like we had intuitively decided that there's something called as criticality ratio, which is a ratio of the cost of underage to the sum of the cost of overage and cost of underage. Now this criticality ratio will help us decide how many to order. Right, that's the first part, which we had, like I said, intuitively figured there has to be something like that. Right. There are videos on how to arrive at this exact formula, but at this point, that's not important. So, criticality ratio part 1 done. Part 2, we said that the demand was variable. So, wherever there's variability, we need to bring in something about that variability or probability into the picture. And so, the stocking point, how much to order or how many to stock, is that point where the probability of demand, that demand is lesser than the stocking point, must be equal to the criticality ratio. Do not understand this? Don't worry. The examples that we present should make it clear. So let's assume demand is normally distributed. Is it always normally distributed? Maybe not, but let's assume. So here the x-axis gives us the various values of demand. We said demand is variable and the mean is 150, but it could vary. It could be less than 150, it could be more than 150. And the vertical line tells us the probability of that demand. So here the blue vertical line that you see above 150 tells us the probability that the demand would be 150. 180, which is greater than 150, should obviously come on the right hand side. And this vertical line here, the red line, tells us the probability that the demand is 180. Similarly, 140, the vertical line tells us the probability that the demand is 140. Now, if I keep drawing lots of lines from 140 on the left hand side till infinity, and the sum of all these lines, which is the same thing as the area of the shaded region, is the probability that the demand is less than 140. All right, remember this, and we see 3 examples which should make this intuition clear. Case 1, remember this is the cosmetic product. Demand is 150 units per day. Variability is something, it could be some standard deviation, we're not as concerned here. The cost of the product is $10, selling price is $35, salvage value is $2, so cost of underage is 35 minus 10, which is $25, and cost of overage is 10 minus 2, which is $8. Right, so CR, criticality ratio, obviously is, you look at the formula at the top, CU divided by CO plus CU, which is 25 divided by 25 plus 8. And yeah, so with this formula, we get an answer of 0.76. And if you look at the normal distribution, the shape, the total area under the curve should be 1. The sum of all probabilities has to be 1. And half of the curve up to 150 is 0.5 or 50%. So since we want 0.76, the probability that it's the CR is 0.76, it's going to obviously extend to the right of 150, and that's what our stocking point is. It's some number which we can calculate, but it's some number which is more than 150. Now let's look at the second case. Let's assume all I changed here is the selling price, P. I made it $118, just $18, so that CU and CO now both become $8, and criticality ratio becomes 0.5. And as we know, 0.5 is exactly at the middle of the curve, the center of the curve. And we should stock exactly 150 units if the criticality ratio is 0.5. And lastly, the last case is when this is our grocery product, when the selling price is only $15. So the cost of underage becomes $5. Well, in this case, the criticality ratio is 0.38, and 0.38 is less than 100 and is less than 0.5, and so this area should typically be left of 150, just something like this, and we would order something which is less than the average demand of 150. So let's combine all these three cases and build up some set of principles. What we are essentially saying here is that if customers are more important, right? Like maybe your product is perfumes or some specialty shoes. If customers are very important, well, we should stock more than the average demand. Well, if the cost of lost customers or lost sale is the same as the cost of excess product, both are more or less equal, we should order equal to the average demand, which was 150. And lastly, if the products are highly perishable and you cannot dispose it, the huge cost to dispose products is, so the cost of disposing or the cost of having excess products is way more than the cost of lost customers. In that case, we must order less than 150 or less than the average demand. So next time you go out to a supermarket, look around. Check the products which have high stock and check products which have low stock, and think, for the products that have high stock, is the cost of underage actually greater than the cost of overage? And similarly, for products which have very low stock, think about it. Is the cost of overage actually excessively greater than cost of underage? Well, if you just do this analysis, I think you would have a very good feeling of the news vendor model and how many products to stock when we face an uncertain demand. Thank you for listening. If you need additional videos on how to actually do the calculations, I will provide the links. Enjoy them. Thank you again. Goodbye.